Hello everyone, myself Jayanth and I am currently pursuing my BE in Sri Venkateswara College of Engineering. I am studying in the third semester and the branch is Artificial Intelligence. The course title is Oops with Java and the topic which we are going to discuss today is sparse concept. The topic which we are going to discuss today is Mastering Object-Oriented Programming in Java, Principles and Practices. Introduction to Object-Oriented Programming in Java. Object-oriented programming is a programming paradigm that uses objects and classes to structure software. In Java, object-oriented programming principles enhance code reusability, maintainability, and scalability. This presentation will explore the fundamental principles and best practices of object-oriented programming in Java. Key principles of object-oriented programming. The four core principles of object-oriented programming are encapsulation, abstraction, inheritance, and polymorphism. Understanding these principles is crucial for designing robust and efficient Java applications. Each principle contributes to the overall structure and functionality of the code. Let's discuss about encapsulation. Encapsulation is the bundling of data and methods that operate on data within a single unit or class. It restricts direct access to some of the object's component, which helps to prevent and misuse of the methods and data. Encapsulation in Java is a key concept in object-oriented programming that focus on building data and methods that operate on data with a single unit known as classes. This practice restricts external access to an object's internal state and helps maintain control over how data is modified or accessed. By making variables as private, encapsulation prevents direct access from outside the class, thereby protecting the data. Instead, controlled access is provided through public methods, commonly known as getters and setters, which allows reading and modifying values while enabling validations or check if necessary. For example, a person might use private variables for name and age while offering getter and setter methods to ensure only valid data is set. Encapsulation improves code security, enhances flexibility, and ensures that the class internal working can change without affecting other parts of the program. This approach makes the code more maintainable, secure, and reliable. Let's know what is abstraction. Abstraction involves hiding complex implementation details and showing only the essential features of the object. In Java, this can be achieved using abstract classes and interfaces, allowing developers to focus on interaction rather than internal work. Inheritance in Java. Inheritance allows a new class to inherit properties and behaviors from an existing class. This promotes code reusability and establishes a hierarchy between classes. In Java, inheritance is implemented using extends keyword, facilitating the creation of specialized classes. Let's know more about inheritance. Inheritance in Java is a way to create a new class based on an existing class. This helps reuse code as the new class can use methods and variables from the old class without writing them again. Java uses the extend keywords to show that one class inherits from another. For example, a dog class should inherit from an animal class, gaining abilities like eating, while adding new ones like barking. Java supports type of inheritance like single and multi-level but not multiple inheritance directly. The super keyword lets a child class call methods or constructors from its parent. Polymorphism. Polymorphism enables objects to be treated as instances of their parent class. It allows methods to do different things based on the object it is acting upon, enhancing flexibility and integration in code. In Java, polymorphism can be achieved through method overriding and overloading. Let's know about different types of polymorphism. Compile time polymorphism, also known as method overloading. This occurs when multiple methods in the same class have the same name but different parameters. The method to be called is determined at compile time based on the arguments passed. The second one is runtime polymorphism, also known as method overriding. This occurs when a subclass provides a specific implementation of a method that is already defined in its superclass. The method to be called is determined at runtime. Benefits of polymorphism. Flexibility allows using a single interface to represent different types of object. The second one is code reusability. Enables using the same method names for different functionalities in different contexts. Maintainability makes it easier to modify and extend code. Let's know how to design classes effectively. When designing classes, consider the single responsibility principle. Each class should have one reason to change, promoting better organization and easier maintenance. This principle helps in creating cohesive classes that are easier to understand and test. Let's know about interfaces and abstract classes. Interfaces and abstract classes are both used to achieve abstraction in Java. Interfaces can only contain method signatures and final variables, while abstract classes can have both abstract and concrete methods. Choosing the right structure is essential for effective design. Let's know about using design patterns. Using patterns are proven solutions to common problems in software design. Familiarity with patterns such as singleton, factory, and observe can significantly improve your object-oriented program approaching in Java, leading to cleaner and maintainable code. Testing in Java. Effective testing is crucial in object-oriented programming. Techniques like unit testing ensure that individual components work as intended. Java frameworks like JUnit facilitate the testing process, allowing developers to validate their classes and methods systematically. Let's discuss about common pitfalls in object-oriented programming. Developers often encounter pitfalls such as over-engineering, excessive inheritance, and neglecting encapsulation. Recognizing and avoiding these common mistakes can lead to more efficient and manageable code bases, improving overall software quality. Mastering object-oriented programming in Java involves understanding its core principles and applying best practices. By focusing on encapsulation, abstraction, inheritance, and polymorphism, developers can create robust and scalable applications. Continuous learning and adaptations are key. So this was all about object-oriented programming concept. Thank you for watching the video.